In the polar coordinate system, functions are written in the form r equals f of theta. Graphs of polar functions can be created in the same way that we do with rectangular equations, by taking different values of theta, plugging it into our equation, and calculating the corresponding values of r. Then we plot those points on a polar coordinate system. Now, these are generally a little bit difficult to draw simply because you need a lot of sample points in order to see a good picture. But at the end of this example, I'll show you how your calculator can do this as well, in case you have forgotten. Okay, so we have, in this example, the function r equals 4 sine theta. So what I want to do is pick different values of theta and then calculate what the value of r is through the function 4 sine theta. And I definitely need to go through the entire unit circle, or the span of 0 to 2 pi, just to make sure that I see everything. But choosing the values to pick here aren't always entirely obvious. You're not necessarily going to get a great picture with randomly choosing values. What I tend to do is just start with easier values of theta to work with. So for instance, 0, and it's probably worthwhile seeing what's happening in quadrant 1. So we could do pi over 6, pi over 4, then pi over 3. And that would take me to pi over 2, which is the next quadrantal angle. And then from there, I think I'll just do multiples of pi over 4. So the next one would be 3 pi over 4, and then pi. And I'll see what it looks like at that point and decide if I need to go further from there. Okay, so the value of r, we don't have to calculate x and y like we did with calculating coordinates. We just need the value of r. So we have the angle measure. The value of r would be 4 sine 0 in this case, which sine of 0 is 0, so the radius is 0. So that means my first coordinate pair is theta equals 0 and r equals 0. Or I suppose that's the other way around. R equals 0, theta equals 0. The next point, I would be doing 4 sine pi over 6. And sine pi over 6, that's one that you should know. Quadrantal sine and cosine angles in the first quadrant you should know. In this case, that is 1/2. So this would be 4 times a half, which is 2. So then I have a coordinate at 2 and pi over 6. So I just find the pi over 6 line and plot 2. Pi over 4, then I would be doing 4 times sine pi over 4. Pi over 4 for sine is the square root of 2 over 2. So this is essentially 2 square root of 2. And if you don't know exactly where to plot 2 square root of 2, you should estimate it on your calculator. So 2.8 approximately. So we'll go with an angle measure of pi over 4 and then almost out to a radius of 3. All right, next we have 4 sine pi over 3. So that's going to be 4 root 3 over 2, which is 2 root 3. And again, another one I need to estimate. So 2 root 3 is 3.46. So on the pi over 3 line, I go about halfway past that point, between 3 and 4. Pi over 2, then let's see, so 4 sine pi over 2. Sine of pi over 2 is 1, so this would just be 4 times 1, which is 4. So that's plotted there. 3 pi over 4, that's going to be 4 times All right, so the y coordinate is positive here, so that's going to be positive root 2 over 2, so 2 root 2. And if I recall, that was 2.8, so along the 3 pi over 4 line, I go just almost to that point. And then at pi, it would be 4 sine of pi, and that is 0. So we're back to here. All right, so I don't have a lot of points on this side, but I do have some points here, and I'm going around these like this. And I think that same pattern is going to happen over this way. And this would essentially be the graph that I'm looking at. It is supposed to be a circle, but you know, perhaps the scale's off a little bit that I've plotted these points on, so mine doesn't look quite like a circle, but it is supposed to be a circle. I'll show you here. And that'll give you an idea of how you can actually graph these on your calculator as well. So make sure you're in the correct mode. So you want to be in, let me make this larger for you. You want to be in radian mode for one, and come down to, instead of parametric or function, you want to go into polar mode for graphing. So now when you hit y equals, everything's in terms of r and theta. So let me clear out what I have so far, and we are graphing 4 sine theta. When I hit graph there, well, actually, let me check my window first. Okay. All right, so theta min, theta max, I can go from generally 0 to 2 pi. Whoops, what did I get there? 2 pi, there we are. It generally handles all polar graphs pretty well. Theta step, you want to have something small. So I tend to do like pi divided by 24. And that way the step increments are in terms of common angle measures, but also a fairly small increment, because I generally use a theta step of 0.1 in rectangular coordinates. X min, X max, let's go with -5 to +5 on each of those. And I'll hit graph here. All right, so there it is. It looks like an egg instead of a circle, but remember, there's more pixels in the horizontal direction than there is the vertical. So if you hit zoom square, so hit the zoom button, and option 5 is zoom square, it will make sure that the same number of pixels are matched up with your axes in the horizontal and vertical directions, so that it looks like what it's supposed to be, which is a circle here centered at the a little bit above the origin at 2, 0, 2.